you've been added to the platform. Now let's start.
Okay. Yeah, it's on mute now. Thank you. All right. So where we learned that software engineering is a process of developing software. It's not just the act of typing it on the keyboard like writing code. In contrary to what some expected, some of the students have expressed concern that what they think software engineering is just to write code and develop software. And that is their aim of coming. And we have tried to prove it wrong that software development is just an aspect. In fact, it's not the most important aspect because we have DevOps, we have project manager who we even oversee in a standard setting. So software engineering is much more than writing code. We established that in the first week. On the second week,
The one that was just really like PDP.
right?
PDP.
No,
I think we're going
You
to
say?
avoid.
it's clear.
Okay.
Really?
That's what I mean. I look like.
Wanna clap for them? Wow, that's good.
Okay.
Okay, so I will not share my
Share
screen.
screen.
Okay, so this thing that happened just happened so that someone that didn't come on time will be here in this class because we would have started. My screen has not shown. Stop sharing. See, I'm not sure. Okay, let me share. Is my screen showing there?
Not yet.
I'm sure it will. Right. Is it going to trade?
Okay. Those of you online, we're sorry. Please, can you hear me? Okay. We're sorry that we had this issue. So I think what we're going to do is we're going to change systems. I'm going to give my own system to use while I go to my office and sleep because I actually came here to work on some other things that I'm working on. And now I have to let that go and sleep in the office. So you sent it?
Yes.
I'm waiting for you. I'm still waiting for your slide to run on my system. Let's share it. Those of you online, can you still hear us? Those of us online, can you still hear us?
Yes. Yes.
Okay. Are we still audible? You can still hear us. It's working fine.
What about the visual?
The audio and video are working fine.
The screen has been shared.
Okay, so I'm coming. Okay. You can still see my screen? Okay. You gotta have mercy on my soul, man. Yeah. So what's the code, please? QEMP GHZ what? GE
QENT. But I was thinking it's going to change. It's not going to
It's
change.
supposed to change.
Okay. QENT.
QEMP
GH.
GH
Exactly.
It's not M, no, it's N.
M. It's not to load up on it. You can read that. Come to me.
QENT. GH. Exactly.
Please, you can turn off your mic.
All right. Thank you very much, sir.
All right. Please turn off your audio.
Okay, so we apologize for that technical hitch. So we progress. We have already introduced the class today. And what we said that time was that this introduction to software engineering is the fourth week. So it started 3 weeks ago, or let's say 4 weeks ago, 3 weeks ago. The first week, we discussed that software engineering is a process of developing software. It is much more than the act of typing code on the keyboard, contrary to what some persons are thinking, that software engineering is programming. It is not. The second week, we look at software development lifecycle. Those things that software engineer need to do that differentiates him from just a software developer or just a programmer. A whole lot of things. And those things are the things you need to learn. Those things are the things that you need to know. Those things are the things that people that are studying software engineering in any of the universities in the world, that's what they study. And it takes like 5 years or 4 years, depending on the institution. Those are those theories that you see there. And you have to take them seriously. The third week, we discussed about front end. And we said that as a software engineer, you can choose to add front end development to your skill so that where you are not working as a software engineer, you can specialize in front end. While being a software engineer, you can specialize in front end. Today, we want to talk about back end. And we are using the same phrase that while you are a software engineer, generally, you can decide to major in back end. Having established that software engineering is not programming, programming and software development is just an aspect, one of the areas you can measure. One of the areas you can measure. It is not the most important area because we have DevOps and we have project management or project manager. These two, as I don't want to say that they are superior, they are not superior, but they will supervise software developer or they will supervise a programmer in a normal software development setting. This is by no means saying that software development is not good. In fact, that is my own major. I'm a software developer too. In terms of, as a software engineer, I major in software development. I didn't major in DevOps. But I noticed that anytime we are having a normal setting, DevOps supervise us. But I don't feel bad because I know I'm a software engineer. I know what you know by theory, even though I'm not practicing it because that's not where I major. So you can choose to major anywhere. There is no area that is inferior. There is no area that is superior. It's just division of labor. Because apparently you cannot do all that is required. So there's a difference between a programmer who went to business center to learn programming. You know you can learn it there. Or those who sit in their house and learn it on YouTube. There's a difference between those people and you that is a software engineer and then a programmer. Two of you are doing the same task, but you don't have the same knowledge. Your own is high. You know that you are superior to that person that just like someone that go and learn mechanic and someone that read mechanical engineering. Two of them are not the same. So that's why you are passing through a university for this knowledge. Even though the entire software engineering course that you are doing under this ideas project, we take it to software development because that's the only area they want to major in this course. So everybody here will still go to software development to major as far as this project, this training is concerned. But with this software engineering introduction we have done, we now know better. Is it not? So let's look at introduction to back-end development. Back-end development refers to the server-side part of web application or software. It involves working on the database, server, and application logic. We have mentioned three things here. Database, server, application logic. The back end is responsible for storing and managing data, ensuring everything on the client side functions smoothly by providing necessary data. You know that last week we talked about front end and we say it is the side that the user interacts with on our system. Why the back end? We don't see that back end. It is the database side of it. Look at the key components of back end development. Server, which handles requests from the client browser and provide response. Database, which stores data. Example is user data and application settings. Then we now have application logic, which is the processes and that manipulates data as needed, such as calculation, managing user session, logging in, authentication, and all that. We saw this diagram last week. So you see where front end goes. We talked about it last week. So this week now we're looking at the right side of it. That is the back end. So you see where the application logic comes in and the languages we use for them. Also see where database comes in and the languages we use for them. We have said it before, I'm saying it again. No language is superior and no language is inferior. Don't think that because you're writing Python, you are superior to someone writing Node.js. It's not true. And don't see someone writing C# as is lower than someone writing Java. It's the wrong knowledge. All these things are different languages and different technologies owned by different companies. So there is no superiority. They are all, any code you write with them will work. What is important is the knowledge of the developer, the knowledge of the programmer. Their knowledge level is what differentiates. But there are certain things you'll be doing that you will require certain language. For example, if you are doing something that have to do with machine learning, AI, you will look at Python. You will consider someone that is writing Python. If you are developing software for federal government of Nigeria, you will consider C# because it's Microsoft technology. And Nigerian government is partnering with Microsoft technology. That's why they value C#. If you are developing a software for individuals or companies, you can use PHP, you can use Node.js, you can use C#. But they may not want C# because it's expensive to host. So you consider Node.js and PHP. So that is how this thing goes. Besides these differences, the language is a language. So you learn the one that suits you. We'll talk more on them. Common back-end tasks. What does a back-end person need to do? Number one, you write server-side code. All those logics and algorithms, you write them. Next, handling HTTP requests and responses. Integrating with databases. So this is we call CRUD operation. CRUD is create. What is R? Read. Read means extract or fetch. Then U is update, and D is delete. So these are the operations we do on the database. We'll talk more on them too. Then user authentication and authorization. Then working with APIs. These are the job of a back-end developer. So if you are already a back-end developer or you want to be, consider that you learn these things. If you're learning it from someone, make sure the person shows you how you can write the codes, these server-side codes, using the language you prefer or choosing. Then you have to handle HTTP requests. That one is just nothing. As long as you know how to use form, you've known how to use the request. Then integrating with database, of course, that's the essence of that end. For you to submit, perform this CRUD operation is also common. It's not something you bother to check because that's the first thing. You can, even in business center, you learn it. That's what most people think is back end. Just submit data to database, manipulate it, and fetch. But that's not the end. You should also learn how to authenticate users, how to do login. Make sure the person can sign up, login, remember password, and also change password. That's the four things that make up the authentication. And now they're adding two-factor authentication, so you can as well add it because it's the modern thing. Then how to work with API, very important. API will allow you to work with different technologies. The role of backend in full stack development. So we know the ones we call full stack. These people can write both back end and front end. So engineer is a full stack developer. So you can as well be, or you measure. If you want to be a freelancer like me, maybe you consider taking full stack. But that does not matter anything. Even if you major in front end, you can still be a freelancer. If you major in back end, you can still be a freelancer. And you can get job in any company you like if you want to work in a company, no matter the stack you choose. Interaction flow. The user interacts with the front end sends requests to the back end processes the request, interact with database, and send the response. The front end displays the data to the user. So that is what happens at the full stack level. So you do both front end and back end so that you can get requests from user, process it, send to database, get from database, and return back to the user. You look at common back-end technologies. The first thing to consider is the language you're using. And these languages are used for writing logics. The back-end technologies, their language is used for writing logics. The first one highlighted is Python. If you want to be using Python for programming, especially for web design, you have to consider Django or Flask as a framework. If you're using Node.js, which is based on JavaScript, you have to consider using Express along with it. Node actually is not a programming language. I hope you know. Okay, you don't know. Node is not a programming language. It's like a platform where you can write JavaScript. And the technology you can use with it is Express. But all of them belong to JavaScript. I think that the software development technology they will give you guys in this training is Node.js. That's what I think. Except they will change it. But Node.js is a quality. Next is Java as a programming language. Java is used in enterprise level application. So you can consider using Spring Boot if what you want to use is Java. You tell the person to teach you Spring Boot. Ruby. So this one is Ruby on Rails. That's what we call it. If you want, that's the framework for it. Then you have PHP. So these are languages you can use. The next technology is the database. That's technology 2. Technology 1 is programming language. Technology 2 is databases. What database do you use? Databases are used for storing and retrieving data. So you can use SQL-based database. So these SQL-based databases are for relational tables. It is the most used. In fact, since the beginning of programming and software development, it has been SQL. That's why it is the most popular. More than 90% of software and websites running on Earth is based on SQL. And I don't think SQL will go out anytime soon, even though there are new technologies threatening it. If you are using SQL, then you consider MySQL, PostgreSQL, SQL Server, Oracle. These are SQL-based databases. So they store their data in tables with structured relationship. That's the difference. Now, the one that is threatening SQL is the one they call NoSQL. They say this one is NoSQL. So these databases are non-relational. So the difference between SQL and non-SQL is that SQL works with relational database, relational tables. But no SQL doesn't work with relationship. It doesn't recognize relationship. It works on its own. It doesn't have structure. It flows like liquid. But SQL have structure. The structure of SQL is table that have relationship. But no SQL doesn't work with relational databases. Example of NoSQL is MongoDB, Redis, CouchDB. There are so many of them too. But like I said, they cannot replace SQL because SQL, there's a straight line demarcating them. Relationship, no relationship. There would have been a threat if all of them are doing the same thing. Because these new technologies now, they are faster than SQL. That's the credit to them. But they cannot replace SQL. So they store data in a flexible format like documents or key pair values. So most of the times you see these no SQLs, just to appear different, they behave like XML. If you have seen XML, that's how their codes look like. We are talking about technologies you consider as a back-end developer. One of them is language. The other one is your database type. The third one is the framework that you are using. So as a software engineer, you will interview a developer. That is how high software engineering is to just developer or programmer. Now, during the interview, you are supposed to find out these three things before you can employ the person, to be sure that it suits the objective of your company or the objective of the task at hand, the software you want to develop. First, you check the language the person is using. Two, you check the database that the person is familiar with. Now, thirdly, you check the framework that the person is familiar with. Express is the framework for Node.js. So it's for JavaScript stack. The Django is for Python. Spring Boot is for Java. Laravel or CodeIgniter is for PHP. So all these are frameworks. And you as a software engineer now, who want to major in software development, you choose the appropriate framework. Why we mention this framework is that these are not the only frameworks. There are so in PHP family, we have E, the one they call YII. There are others, so many others. The same with Java, the same with Python and Node.js. But these ones we mentioned here are the ones that are sellable, the ones that are very important, the ones that are superior to others, if I may use that word. So when you are choosing your language, make sure you are using the sellable framework. Don't go and use framework that is old or framework that is not approved or framework that doesn't meet international standards. That's why we listed these ones. In case you are choosing any of these languages, make sure you are applying them to these frameworks. The fourth thing you ask the person if you are interviewing him, or the fourth thing you should learn if you are the one doing the software development, is API. So we have two APIs, and any of them goes. The REST API is the one that we know, is the one that has been since the world began. REST is representational state transfer. It's a standard for building APIs. But this new generation of NoSQL, they now have the one they call GraphQL. So this is a new one. So if you have the opportunity to learn it, learn it. But the one they may teach you in every average institution is REST API. And like I said, more than 90% of the software we have, even on the internet, offline, everywhere, even mobile, is using REST API. So this GraphQL is new. They will start changing the world soon, but they have not started yet. But it's in use. What I mean is that they have not taken over from REST API. So these are the things we learn. So these are the four technologies that you must embrace in the back end, if that's where you're majoring. One is the language, 2 is the database, 3 is the framework, 4 is the API. So what are the steps to build a simple backend application? Number 1, you set up your development environment. So the development environment is what we call IDE, where you write your code, connect your database, and do all your work. You set it up. Some people are using VS Code. If you are used to PHP, there's the one they call PHP Storm. If you are used to C Sharp, there is one they call C Sharp.net. Or VB.net is no longer in vogue, so it's C Sharp.net. So you download .NET environment. That's the idea. I think Python has Anaconda. Or there's also the one they call PyCharm. So these are IDEs that you can use for each of them. So when you have set up the environment, then you download the framework you use, either the Django, Express. When you download it, you set up your database. Then you create your basic API. Then you define your models, that's the data structures. Then you create endpoints. APIs are called endpoints because they are the link between your application and another application. So database also have a life cycle, just like the software itself. This is the software, the database different life cycle. One is requirement analysis. You must understand what is required by going to the person and asking questions. Do not make assumptions. You will do assumptions after the person have exhausted what he's telling you, and you have exhausted all the questions you need to ask. Don't have a question and keep it in your mind and use your personal assumption. You can make a mistake. Let's say, for instance, you are developing a software for a school and students are involved, and you want to collect student data. And you didn't ask them, what and what should I collect? Is it only name, gender, and phone number? Or do I need address, age, height, and weight? You didn't ask those questions. They say, collect data for, we want to store information about our students. And you just go, you didn't ask them the things you need to collect. You will make a mistake. You either we collect what is not needed, thereby consuming system resources unnecessary, or there may be important things that you didn't collect. So first of all, you have to understand the objective of the software and then ask questions. What and what should I need to collect? It's very important too. Then from those things now, you now know how you create relationship for the term. That requirement says understanding the need of the users and the business, identifying the data that must be stored and the relationships between different data elements, defining functional and non-functional requirements. After you have gathered the requirements, the next is design, conceptual design. So you create a high-level design of the database, typically using entity relationship diagrams. So we are going to learn this entity relationship diagram. So you define the entities, you define their relationship, you define the attributes. Example, if you want to design a library system, the entities there will include books, students, those are borrowing books. So you can use any terminology you like, so long as you can understand it. After the conceptual design, the next is the logical design. So in this logical design, you translate the conceptual design into a logical structure that can be implemented in a database system. So at this stage, you design a table that is mapped by relationship. And then you define the primary and the foreign keys. Then you normalize the data to ensure the database structure is free of redundancy. So we'll talk about this normalization and how to do it. physical design. At this physical design, now you now determine how the data will be stored physically in the database, considering aspects such as indexing, partitioning, and data types. So designing the storage structure and optimizing for performance and scalability are also part of the physical design. The fifth of the life cycles of database is implementation. So when you are done with all these designs, you can now give it to a programmer or to a developer. They now translate the logical design into actual database. They now create the tables and the views, and then populate the table with data. So they ensure that the design is correctly implemented. That is your job now. After they are done, you ensure that the design is correctly implemented in the choosing database management system. Then, maintenance. So after implementation, there's continuous monitoring, backup, optimizing the database, and ensuring that it's running smoothly. So that's the maintenance there. You'll be backing up regularly. Because if you don't back up and anything happens, it's better that the system crash than the database crash. Because all the needed, it's just like phone. No matter how costly your phone is, if you have used your phone for 2 years, if you are asked to choose between that phone, no matter even if it's iPhone 11 and your SIM card, assuming there is no place that you back it up, you choose your SIM card, is it not? Okay, those using iPhone say no. Okay, because it's expensive, but I also know why they didn't talk. Because that backup has already been done for you in the iCloud, is it not? So, okay, let's remove those using iPhone. Let's say those that are not using iPhone. Android phone. However, but you understand what I'm saying? The storage is more important than the device. And that's how it is in every setting, both in software. The database part is the most important part because that's where all the information is stored. Other ones can be redesigned, but you can't redesign database if you lose it. So long as it's being used, data is being submitted to it, retrieved, edited, updated, deleted, you can't replace it because you won't see it any other place except you back it up. Now, entity relationship modeling. This is very important. When we say that one of the critical jobs of a software engineer is to produce documents for your design. Those documents will include this entity relationship diagram. Because that's what will help another person to know what you did on the database, and that's what will also help you to know what you did when you come to do maintenance. So try to understand this part. What is entity? So entity represents real-world object or concept. You see, these are university definitions. Each entity has attributes that define its character. So bringing it back to practical, to physical, what we mean by entity is that object we want to design the database for. That's what is entity. Let's say that the university call you to develop a software for them for their library. You know that you're going to design a database that will store library users. That is students. Students is an entity. Books is an entity because you are going to keep record of the books that they are taking. If you are developing a software for sales in a marketing setting, so customers is an entity. The product that they are selling is an entity. So you need to understand what entity is. But it's not a hard thing. You don't need to cram it. It comes natural. Once you learn how to develop database, each table you're creating is entity. Okay, I think that's the best way to put it. Each table is an entity because one entity must go into one table on its own. It doesn't have to have another thing joined to it. And that is also where normalization comes in. We will talk about normalization. Normalization means don't repeat and don't join unnecessarily. Let each thing be on its own. Let each thing be on its own. Then you create relationship to join them. That's also why I say that this NoSQL cannot replace SQL because the way we live, we can't do without relationship. And it's SQL that creates relationship. So entity is one table. Say entity is table. Entity is table. Remember that. Yes. Now attributes. Attribute is property or character of that entity that you want to store. So when you have a table, you now have columns. So attribute is columns. Those columns, what you put in them is what is attribute. Like now, if you want to store a customer, just like the example we have here, the name of the customer, the email, the phone number, address, all those things form attributes. But in real practice, we call them columns or fields. Then the next thing to consider is the relationship. So the relationship now defines how these two different tables we created will relate to each other. Like from the example here, the customer is placing order. Order is an entity of its own because there will be a table for order. There will be a table for customer. You now connect a relationship between them. You use a diagram to show this relationship. That's what this entity relationship diagram is. We have these types of relationship. We have one-to-one. If one table connects to one table only, we have one-to-many. If many tables connect to one, and that means that table must be important. Then we have many-to-many, where many tables connect to many tables, making a complex kind of table. Then we have notations in entity diagram. We have already talked about the entity being the table. So we represent it with rectangle. For attributes, we represent them with ovals. Oval is something that looks like circle, but it's not perfect circle. The relationship is with diamond. Diamond is kite, something like this. That's what we represent it. Then in the cardinality, we have one-to-one, use red line. One-to-many, we use crow's feet. There's something they call crow's feet. That crow's feet will be at the end where many is. So if you see an entity relationship diagram, you look out for that crow feet. Anywhere you see that crow feet, that means there's many there. Many is connected to that table. Then many to many, we have crow at both ends because this is many, this is many. See what we mean? This one, the right many is the crow feet. This is what we call crow feet. Anywhere you see this, it means that there is many there. Like if you look at this place now, you see one-to-many, you see zero-to-many, you see many. This crow feet is the identity. A company is giving one car to their employees. So they bought cars and they want to give one employee one car, one employee one car. This is how to represent it. So you can see here, car is a table of its own. Employee is a table of its own. Then this diamond shows a relationship and is one-to-one. Now in the table or in the entity called company cars, the attributes or the columns is this car ID, license number, model year, make, and model. Then in the employee table or employee entity, the attributes or the columns you see there is employee ID, first name, last name, full name, address, city, state. Now see this car ID here. It's repeated here. So let me ask you, which one is the primary key? The car ID in company or the car ID in employee? Which one is foreign key? The response is no. Okay, we'll still talk about those things again. But see how these tables are connected. So we make a design like this. As a software engineer, when you are preparing your documents, you will have a design like this. It's part of the diagrams. It's part of the contents of the document you are going to produce. It's called entity relationship diagram. So seeing this sign here, I know that this car means many. Is that right? So one person can own more than one car. Is it possible? So that's what this diagram is showing us. Now look at the tabular representation or the entity representation. Owner is an entity. And you can see the attributes to that. Now look at car. So this car, you can have many cars, and each of the cars will have these attributes. Then each car has how many engines? So this is 1-to-1. One car, one engine. But you can decide to do without the engine if it is not important to what you do. What we are considering is this many here. Then this is many to many. I don't know why this didn't show the signal. Many order, many product, many. Okay, one category. So one category can have many products. For example, electronics is a category. Under electronics, you can have phone, laptop, television, many products, one category. Then the many to many we're talking about now is order and products. Many persons can order for one product and can also order for many products. You can come to an electronic shop and you buy phone, you buy laptop, you buy this one at the same time, and you order for them. So there can be many orders and many products. And that same product you ordered for, another person can still come and order it again. So there is many to many relationship in this one. And when you want to show it in the entity diagram, you remember this profit. That's what you use to show it. Example of entity relationship diagram. Consider a simple university system where entities now, or tables, can be students, course, and instructor. In the relationship, students enroll in the course, instructor teaches the course. Student has attributes like student ID, name, date of birth. Course has attributes like course ID, course name, credits. Instructor has attributes like instructor ID, name, and department. Now, students enroll in course is many to many relationship because there are many students and there are many courses. A teacher can teach more than one course. So we have one to many relationship. So these are some of the things we need to put in mind. Relational model and tables. Key concepts. So relational models organize data in tables, also called relations, consisting of rows, tuples, and columns, attributes. Each table represents a different entity. We have said that before, that entity is table. And relationships between entities are represented by foreign keys. The primary key is a key that uniquely identifies each row in a table. Example, in a customer table, customer ID might be the primary key. Foreign key. A foreign key is an attribute in one table that links to the primary key of another table. Example, in an other table, customer ID may be a foreign key linking back to the customer table. That's okay. Yeah. Relational integrity. We have entity integrity, which ensures each record in a table is unique and the primary key is never known. Referential integrity ensures that foreign keys accurately point to valid records in another table. So that makes it a foreign key. So how do we create a relationship schema? So given your entity relationship diagram, you map it into relational tables. So for example, you have customer table. Here we have customer ID as primary key, name and email. We have other table that have other ID, other date, and then customer ID as foreign key. Let's look at this normalization. At this point, I wanted us to make some drawings. I think that's what we should do before going to okay. Let's finish normalization. We now go, when we are doing practical, we know we are doing practical. So normalization is the process of organizing the database into tables to minimize redundancy and dependency. The main goal is to ensure that the data is logically stored, with each fact being stored in only one place. This process involves breaking down larger tables into smaller, more manageable ones, ensuring that each table represents a single concept. So what normalization means is that they don't want tables to repeat, and they don't want your data to be repeated. That is why we have primary key and foreign key. So that those things that should repeat, we use keys to link them instead of repeating them. We'll see how it works. Then we have levels of normalization. First normal form, second normal form, third normal form, and voice code normal form. So at your own time, you can look at these normalizations to understand them more. Benefit of normalization, they reduce redundancy. What they call redundancy in database is storing the same information in more than one place. That's what's redundancy. You're not supposed to store one information in more than one place. You put it in that place, you now use key to link. Okay, I'll check it. Another benefit is it improves data integrity. Efficient updates. Because the data is stored in one place, once you update it, it updates across board. But if it is in many places, you need to be going to those places to update. And if you miss to update one, you cause problem because the information here and the information here will no longer be the same. Then it simplifies data management. Of course, because those data are in one place, so you can manage it. So I want to see where the people online say they have questions. The questions they are asking online is irrelevant to what we are doing. How to submit assignments, that's not what we are talking about now. Okay. Denormalization. So while normalization is very strict, it doesn't want any data to repeat. That's the sense of normalization. No data should repeat. But if you do it that kind of dry programming where you don't want anything to repeat, sometimes for you to fetch a certain kind of data, you are going to write a long code. So when we look at such critical situations, you can decide to let go. You can decide to at least make some repetitions, bearing in mind that we should not repeat, but we just repeat a little to make sure that we don't write too many codes trying to resolve fetching of data. So that's what is called denormalization. Normalization is completely strict. Don't repeat any data. But denormalization allows you to repeat some, make some redundancies. So reading it here, it says, while normalization reduces redundancy, it can sometimes lead to performance issues, particularly in read-heavy applications. Denormalization is the process of intentionally introducing redundancy into a database to improve performance. It may involve merging tables or adding redundant data to reduce the need for complex joins and queries. If you write your code completely normalized, completely dry, there are some applications that may need some data to repeat. And if you don't repeat it, you are going to use code to repeat it. Your code, you have to go to database, fetch from there, merge it, or what we call join when you are writing database queries. And it takes a lot of resources to run those queries. So it will be better you allow some redundancies to save time. Keys and constraints in database design. So let's look at the keys. We have the primary key, which is the unique identifier for each record in a table. No two rows can have the same primary key. That is, there's no repetition in primary key. No two rows can have the same. Foreign key, a field in one table that uniquely identifies a row of another table, establishing a relationship. So what we call foreign key is a primary key in another table. So we have candidate key. Candidate key is a key or a field or a value that is qualified to be a primary key, but we didn't use it. Maybe because we have something else we want to use. For example, phone number, email address, matric number. All these are attributes of a student. And each of them qualifies for primary key. No two persons can have the same phone number, is it not? No two persons can have the same email address. And no two persons can have the same matric number. So if these three are in a student's entity, a student table, any of them can be used as primary key. And they are all called candidate keys because they qualify for being a key. Just that we can't use more than one as primary key. So we choose the one we want, which is the matric number. So composite key is a primary key composed of more than one attribute. Alternate key, a candidate key that is not chosen as the primary key. So if you have phone number, email, and matric number, and they choose matric number, both phone and email are alternate keys because they were not chosen. And let's look at some constraints. Number one is not null. Not null means that that particular field, that particular attribute must be supplied. If you meet it in a form, maybe you are filling a form, when you click submit and you didn't fill it, they take you back to it and mark it red. And you need to, so the constraint that is controlling that is not null. That place is not null. You cannot allow empty. Then we have unique. Unique is the one that makes it that no two values of the same entity can go in a table. That you can't repeat. That place cannot repeat. For example, when somebody is signing up, you have signed up before, and you are coming to sign up again. You tell you, no, you have signed up before. Log in if you want. Have you experienced that? That's because a particular key there is unique. Sometimes they use phone number, sometimes they use email. So what they usually use for that unique is alternate keys. That is those keys that should have been used for primary key, so that they use it to identify the person uniquely. We also have check. Check defines a condition that must be true for the data to be entered into the column. For example, phone number should be 11 digits, account number should be 10. Those things should be checked so that you don't submit what is not usable in the database. Then we have default. Those questions online are not for me. No, they are asking about assignment. So it's not the right time for such questions. Yeah, that's what the person is. They say ID, class ID. Okay, I'll check it again. We didn't start on time. So we have to take like 20 minutes more. So talk to those online that you have to wait for 20 minutes. So we have the one we call default. In fact, what the system can take as default is what we've given it. If nobody supplies any information, that default will be there. So that's it. Example of key and constraint usage in a table for storing orders. So primary key is order ID, foreign key is customer ID. Not null ensures that order dates cannot be null, and check constraint ensures that quantity is greater than 0. You understand how it works? Because if quantity is less than 0, that means the person didn't buy anything. And if you didn't buy anything, then why should we enter the record? Okay, so we'll do some practice to see how to create a table. I mean, these relationships. So when you are to design a table, each of the entities, you will do this design for it. All these theories that we learn, this is how it come about in the practical. This is how to do it. When you want to design a table, when you want to design a data, you know that a database is a collection of tables. It's made up of many tables. So you design table, table, table. Those tables are what you're designing. You don't design database, you design table. It is these tables, you now call them one umbrella name, database. And as you're designing the tables, you take note of the relationship, where the relationship should be. You also bear in mind that there is something called normalization that is very dry and strict, that you don't repeat your data. So you now create the tables. When you are creating the tables, or when you are designing the tables, not creating, the database development lifecycle says that you have to go and collect requirements from the owner of the software. You now come back and do your design. After doing the design, you take it to a programmer to develop and you now start maintenance. So this is the design now, how to design your database or your table. So you create this table. I can adjust it later. So here you have the fields. So these fields represent the columns or the attributes. This entire table is an entity. So you have fields, you have constraint, you have data type, you have width, you have description if you like. So description is optional. You can decide not to put it. But why is it important you put it? You can give a name here that is not very clear. You now go to description and explain what it means. Let's say that I'm creating record for a library. I'm creating a software for library. So there will be students, there will be books, and maybe there will be a supervisor if I like. Or because of time, let's just do student and book and then see how the relationship goes. So as I'm creating for students first. So I will have student name. I will have matric number. I will have gender. I will have level. What else should I have? Department. So let me stop at this. Okay, phone number or email address. Let me use phone number. Notice that I did not give space why giving this name. We have learned it in one of the classes, either last week or last 2 weeks, that in name, you don't give space. So you either use camel case or you use underscore. So remember that if you give space, you have spoiled that name. The code will not work. One dangerous thing is that you will see all your code is in order, but the software is not working. I saw one picture on social media. That guy, one person is holding a bucket of water. That guy's head is caught fire, and the fire was burning. They're using water to calm it. You know what made the person's head to catch fire? He was editing a code. His code was not running, and he has checked all his code is in order, but the system is not working. So it happens most of the times, and it's because of some of these negligence. If you give space in the name, the system will pick the first name. The system doesn't recognize space. Once it sees space, it will stop. And maybe you put student name with space. It will just pick only students. And in your code, you are calling student name. The wizard will go to fetch student name. You only see students, and it will not fetch it. And you'll be surprised that your code is not running. So make sure that you don't give space. Use underscore or camel case like this. Okay, so in the constraint, there's no constraint here. So you can say, we say that you must put your name so that when we are looking for who has this book, you know. So you can say not null. That means this one cannot be empty. Matric number is the primary key. Gender can be null. If you don't give us your gender, it doesn't matter. You have your name, you have your matric number. Level can also be null. The things you put not null are things that are very important. They are things that are very important. You don't want the person filling the form to omit. You put it not null. But anyone that can be ignored, you put null. Department can also be null. This one is unique. So while we are using unique here, who can tell me what this unique will do? So that same student will not register twice, since his phone number will be used to recognize him. And anyone you say unique, indirectly you have also said not null. It must be filled. Then data type, student is string or varchar, variable character. That's what SQL uses. Matric number is varchar too. Gender varchar. So let me introduce more things for you. Let me introduce more things. Let me see date of birth. And let me see age. So, no. Level is also varchar. So what we are calling varchar is alphabets, strings, letters. Yes. You may think that phone number should be numeric, but it's not. And we are rounding up. So phone number is not exactly numeric. So we can also call it varchar. Numeric, when a number is integer, for example, when you assign a number, a value to the numeric, it means there are some things you can do with it, like calculation. But if a value is non-numeric, maybe varchar or string or you can't use them for calculation. So phone numbers, we don't use it for calculation. That's why we're calling it varchar. And sometimes it can be plus 234. Well, if you choose to use that. But varchar will keep you at safe time because you don't need it. Now, date of birth is date, and age is now integer if you want, or int. Width. Or let me ask, is there anybody that doesn't understand what we mean by data type? I think have we talked about data type before? I don't know what is data type. Let me see hand up. Okay, when you are storing data in a database, you must specify the type of data that you want to store. You must tell the system the type of data you want to store. And like I said earlier, the kind of data the type of data you have will determine the type of operation you can perform on that data. I have said that if your data is not numeric, naturally, you cannot use it for calculation. Like you cannot say A plus 24. It will give you error because A is not numeric. Besides operations, the quantity, the size of memory they occupy differs. Strings occupy more space than numerics. So if you are storing numeric and you say they are strings, you are just bogusly consuming the system resources unnecessarily. That means that your system you design is liable to hang. The system you design is liable to take too long before it will load, consume more memory and all that. So that's what data types represent. And we have a lot of data types. We have int for integer. We have boolean for yes or no, up or down, male or female kind of comparison. We have varchar, that's variable characters, which is alphabetic values. We have char, that is character, the one that is one digits. Like you want to use F to represent female or use N to represent male. Those ones are char, and so on. Now, width means what is the character length of what you want to store. In names, you usually use 60. Matric numbers are how many? Maximum of 12. So we can say 12. Gender is how many? 6. Can be 4 now. 6. Who don't understand what we mean? I don't know why gender should be 6. Let me see hand up. Or I don't know why matric number should be 12. Just indicate if you don't know it. Please, you are learning in the class. You don't be shy. That's what I expect. When the teacher teaches something you are not familiar with, please object and learn it. Don't shy away. So we have said that width here represents character length. How many characters would it be? We put 60 in name because nobody's name has ever crossed 60. Think of the longest name in the world. It's not up to 60. The matric number, some institutions use 10, some use 11. Now, I forgot to say 12 means he may have seen the one that is 12. And that's why I agree with him, because I've seen 10. Gender is 6 because we have female. That's female. That's 6. I know that the guy that said 4 was thinking about male only. Male. But we are gender sensitive. In Polytechnic, it can be now. Are you a student here? Are you a student of this institution? No. That's not a university now. The university doesn't have slash. The matric number is something like 2005421883. That's how matric numbers are. Then level. Level is something like 100 level, 500 level. So level itself is 5 plus the 3 digits, that's 8. Plus the space between them, that's 9. Department can be up to 40, depending on what you are entering. Phone number, what should we write? 11, if you are using 080, if you are to use 2, 3, so 15 will keep us at the safer side. Except we will define it on the table, on the form, that this is what you want. Then date of birth, you don't need to define date of birth. Integer, you don't need to define it. System already have the formats. Any format you choose, system knows what it is. It is the varchars, the variable characters that we define. Then description, like I said, is optional. If there is a field here that you are, the way you name it is not going to be understandable by another person, you can come here and put it. Let's say, for instance, this student name, I did it like this. I did like ST name. I can now come to description and define it as student name, so that anybody that is looking at the table can understand what this ST means. Otherwise, I can leave it without putting anything in description. So this is how to design a table. So I will give you one classwork now before we close, because time, we've been getting signal for other classes to go down. So design a table for the product. No, product. So the product, we have product name, product ID, price, supplier, quantity supplied. So let's take only those ones, then we close. We have only 3 minutes. One thing. Design it. I've contracted you as a software engineer. I want to develop the software we use to manage the product in my shop. Design a database for the product. Design a table like this for products, for the entity product. The product I mean is item I'm selling in my shop. So collect the data that the attributes of that product. And be quick, 3 minutes is what we have. One will leave by 11:30 to another one. Okay. Onyenachi Nwadinobi. You say, what about cross gender these days? If you are doing cross gender, if you are doing cross gender, you count the digits and put it. At least God used to say, don't want to say. That if you know, don't want to say is about 18 or 20. So maybe you put 20. Bags and fruits, say you don't understand. What is it exactly that you don't understand? I don't understand this aspect. Halim Abdul. Halim Abdul, I don't know where exactly you don't understand. Is it the field names, or the attributes, the data type, or is it the width? Which side do you not understand? So I will explain it again. it very 20? Okay. Okay, so let me see what you have done because time starts there. Why do you think that the product price is not still can be just price and change and change price? So the price cannot be except I can't say the price cannot be. It's you that design it. You are sure that no two products can have the same price. So that means that the rest will be. And that is wrong. Why is it because they say price is real and because they say price is real? So why are people thinking alike? No, design a job and doesn't have primary you have failed. In fact, you failed it more than the person that says his price is weak. Because no, price can actually be weak. Depends on what I'm selling in my shop. If the prices cannot be the same, then maybe that's the environment. But every table must have primary key. If you have primary key, what can I make the primary key? Did we discuss it here? Have you heard of the word candidate keys? So you can't have more than one primary key, but you can have candidates. You don't need candidate keys. They are just there. Only you use one. Government cannot be. You don't use names. Instead, you call product ID. Don't use name. Anything name, avoid it as primary. Price as primary. That means we are also saying that price is real. Because primary keys are real. You have to add product ID. Yes, product ID is the primary key. Because naturally,
I said, product price. Why focus? How do I keep it?
you are the one designing. That's what this is called design. And you know that before you make design, you must have gathered the requirements from the owner. So if the owner agrees, if what the owner tells you agrees with what you do, nobody can do it. That's why it's a design. But make sure that the primary and that the primary is also sure. Yeah. Or use the one they call double. Yeah. The one you should have even used as primary is serial numbers. That's the one on that price. No, that's the description, correct. Phone number two, you can go to the description and say 234. So the person will know the type of phone number you want to get. Or you can go there and say 087. So the person will know that. That's what description, yes. You explain what is not here. Alright guys, I've seen what you've done. That is how to design a database. So if I'm designing a second table, since I'm talking about library, I will come here. We are taking other people's time now, but let me just put it. For the library, I will come here and say, I'm doing books now. Book name, book author, student ID that is borrowing the book, dates of borrow. So you can see that student ID has repeated here. This student ID here is the foreign key to this matric number. So what data normalization says is that we don't need to come here again and say student name. Sorry. We don't have to come here and say student name. Because we want to know the name of the student that borrowed this book. We can't repeat student name here. What we just put here is student ID. This student ID will be linked to this matric number. So that anytime a student borrow book, his matric number will be here, not his name. If you now want to know the person that borrowed the book, you go and check the student whose matric number is here. From here, we can now see his name, his department, his phone number, his date of birth, his age. Is that clear? Yes, that book author will give error because there is no link, because there is space. So I can close it and use camel case, or I'll put underscore to separate it. So that is what normalization means. Normalization means these values we have here, don't repeat them here. Just use only one key to link them. And this key linking them is the matric number, which I call student ID here. Then if I'm drawing this, this is one-to-one relationship. So that is the end of the class today, for this class. I will upload this material on the Google Classroom this evening, and there will be an assignment there too, which you can do. Have you done the ones? Why? It's filled up. Okay, we'll address that. Yes? Same issue. Okay, we'll address it. You can give Emma your details so that we know how to do it. But others have done the assignment, back. Okay. The result will be out. You see your result immediately you are done. Yeah, except for the theory, yes. You submitted now. No, it's only one theory. And okay, for the class, yes. That one too. I'm considering whether I should upload it on that platform or not. I will try. Okay. Have a nice day, except you have something else to say. Yeah. So that we can start the second class. Yes. Yes. Next week. The theory part will stop today. We have done 4 weeks.
What time does the class start?
Which bag are you have? No, there is no C. You have only A and B. It's an error. So meet
So when is the
Dr. Hayat. B is starting now. B is the one that will start now. A just ended now.
I mean the software engineering.
It's software engineering.
Even the B, right?
Yes.
Okay, I will attend the B.
Okay.
I will keep attending. Sorry, assignment.
You did it.
So that was last week. I will submit it.
I wasn't asking you to, but you did. That's why I collected it. It will be done online, but you may not need to participate again since I have you. If you choose,
So I did not have it.
the one that's supposed to be online. No. The theory that's supposed to be online. Which online?
Error.
Which error was it showing?
Error.
But others we are doing their own.
Try it again.
But okay, give
And
me.
you try, but you did it like 5 times.
Before, really? Maybe I will check it.
I tried 3 times.
Wow. When you want to submit or why you want to start it. Okay, I will try it. I will try it and check.
So if you wait and then do it online, that was last week.
Yes, online.
No.
No.
What details are they given? Is it their phone number?
Name and phone. They said they can't log into that.
Yes,
So get their name and phone number so that we can use them when it's resolved. Just name and phone number. And tell Mr. Hayat to connect me to the second class. Then we go and get my phone charger. Yeah, it's in the car. You know the people I'm talking about, those who were able to join the Google class.
So when I was trying to do it, this look at what this thing will show. If I was able to snap picture, then the thing is choose to I don't know. It's like best thing. So,
Go to your browser and paste it. Paste it on your browser. You pasted it. Where did you paste it?
go.
Yes, so here is it.
Look at it here.
You see where your own browser is down.
It's very good I'm using.
Okay, H. This way pasted it. I say paste it on your browser. This is where your browser is. This paste it on your browser. I don't understand this. This place is where you paste it. This place now is next. I don't understand it. Press it on your browser, not search. I didn't say search for it. Put it on your browser and press go. It will open the space where you write the text. You do the check.
Okay, what's happened to it? I can see this doesn't want to go.
You press it and drag it. There is nothing. So I put my phone down so I don't feel it. Has it gone? Test it on the browser. Emma? Emma? Come and start this class now.
I think it can but I prefer can't see it. I can go with it.
Yes, you can log and write it. Come and start this class. How far now? Huh? Oh, should we not start the other class? Z? Okay, okay, okay. Let me see what you did on your phone. David, off that phone and keep it. I want to write down my bag.
What? But I think it will get well. I think you won't, okay, you won't show like that. You understand? So if you want like that, no, I'll tell you to show now. I get it the second time. I thought like I was supposed to, so I didn't know it was like, I was trying to complete it so that I could get it.
You like the one that you see.
I look like from the back, so I can do it now.
Now, I will start.
Like when we start normally, I do that.
Yes.
Wow.
Where is Mr. Ayat coming from? He's not there. Let him come now. The time is not. Hmm. Okay.
Have you stopped the other class?
Yeah, I wanted to start now, right?
Have you stopped the other one?
Thanks,
Okay. Fine.
thanks.